For any two sets A and B, if A is a subset of the set B, then we need to show that the Cartesian product of A and C is a subset of the set the Cartesian product of B and C for any set C. Let us begin. So here what we'll do, we will begin by considering an arbitrary element, and that element is going to be an ordered pair. So let's consider it to be x comma y. So let x comma y be an arbitrary element such that we have the ordered pair x comma y. This is going to belong to the set which is the Cartesian product of A and C. Fine. Now we're making an assumption here that this element is a member of the set, the Cartesian product of A and C. This simply means that x must belong to A and y must belong to the set C. Now x belonging to A would also mean that x belongs to B, and we have y belonging to C. Now why does it mean that x also belongs to B? Because it's already given here that A is a subset of B. So we'll write here that since A is a subset of the set B, this simply implies that if we have x belonging to the set A, then it must be true that the element x must also belong to the set B. Fine. So now we have x belonging to B and y belonging to C. In other words, we can say that the ordered pair x comma y belongs to the Cartesian product of B and C. So we started out by considering an ordered pair x comma y, or you can say we an element which belongs to the Cartesian product of A and C, and we were able to show that the same element also belongs to the Cartesian product of B and C. So this satisfies the definition of a subset. We can say hence we have the Cartesian product of A and C. This is going to be a subset of the set which is the Cartesian product of B and C for any set C.